Hello, welcome back. In this session, we are continuing the derivation of the Hermite shape functions. Okay, in the last video, we have taken this element. It has four nodal displacement: vertical displacement v1, v2, and slopes. That is dou v by dou zeta at node 1 and dou v by dou zeta at node 2. Okay, these are considered as the boundary conditions to derive the Hermite shape functions. Okay, these boundary conditions are taken here. This is vertical displacement at node 1. Considering vertical displacement, we have written the boundary conditions. Considering the slope at node 1, we have written this boundary conditions. Similarly, vertical displacement at node 2. Okay, you just make this correction. It is 0, 1 and it is 0, 0. Similarly, considering the fourth nodal displacement, that is slope at node 2, we have written this boundary conditions. Okay, let us derive the Hermite shape function, that is h1, h2, h3 and h4. Let us assume a displacement function as there are four nodal displacements, 4 degrees of freedom, nodal vertical displacement as well as slope in both nodes. We are considered 4 constants here. We have taken 4 constants, that is h1 is equal to a0 plus a1 zeta plus a2 zeta square plus a3 zeta cube. 4 boundary conditions, 4 nodal displacements, so considered 4 constants here. Now to find the h1, let us consider the boundary conditions of the node 1 due to vertical displacement. Okay, what are the boundary conditions for the node 1 due to vertical displacement? That is, at zeta equal to -1, h1 is 1. At zeta is equal to -1, dou h1 by dou zeta is 0. At zeta is equal to 1, h1 is equal to 0. At zeta is equal to 1, dou h1 by dou zeta is equal to 0. These are the 4 conditions taken here to derive the Hermite shape functions 1. This is the assumed function. Okay, this assumption, it is same for all the Hermite shape functions, and we are considering the boundary conditions for this is for second Hermite shape function, third Hermite functions and fourth Hermite function. Let us consider the first Hermite functions, and these are the boundary conditions. Okay, at zeta equal to -1, h1 is equal to 1. Okay, h1 is 1, where zeta value is substituted here -1. Okay, so we got the first equations. Similarly, you apply the second boundary condition. As zeta is equal to 1, h1 value is 0. h1 value is 0 and zeta value is 1. Substituting zeta value is 1, we got this equation. Similarly, you substitute the third boundary conditions and fourth boundary conditions. Now we have 4 equations. Substituting the third boundary condition, we have the third equation. What is this? Zeta is equal to -1, dou h1 by, this is the differentiation of this equation. Differentiation of this equation. See here, it is a constant, there is no zeta term, so it is 0. Differentiating this a1 zeta, it is a1. Next, differentiating this a2 zeta square is, differentiating zeta square is 2 zeta a2. Okay, 2 zeta a2, it is written here. Similarly, a3 3 zeta square, 3a3 zeta square. Okay, substituting taking the third boundary conditions, we have this equation. Taking the fourth boundary condition, we have this. Okay, now using the equation 1 and 2. Okay, let us add equation 1 and 2 to find all the constants. Okay, now we have 4 equations. For the 4 equations, let us find a0, a1, a2, a3. Okay, 1 plus 0, it is 1. By equation 1 and 2, 1 plus 0 is 1. a0 plus a0, it is 2a0. Minus a1 plus a1, it is 0. a2 plus a2, it is 2a2. Minus a3 plus a3, it is 0. So by equation 1 and 2, we got this one. Similarly, by equation 3 and 4, this one, a1 plus a1 it is 2a1, minus 2a2 plus 2a2 it is 0, plus 3a3 plus 3a3 it is 6a3. Now okay, see here we are finding the constants here, all the constants a0, a1, a2, a3 for the Hermite shift functions. Here 2 is taken common, so a0 plus a2 can be written as half. Similarly, by this equation 2a1 is equal to minus 6a3, so a1 is minus 3a3. Okay, now we have a1 in terms of a3 and a0 plus a2. Okay, let us consider this second equation, 0 equal to a0 plus a1 plus a2 plus a3. By this a0 plus a2, a0 plus a2, we have a0, a2 both here, a0 plus a2, this value let us substitute half, and we have a1 value that is minus 3a3, a1 value minus 3a3. Substituting all this, we got, substituting a0 and a2, that is a0 and a2, that is half, and substituting a0 plus a2 it is half, and a1 it is equal to minus 3a3 and it a3. So now by this equation we can get a3 value. A3 value it is 1 by 4. Similarly, you use any, okay, a1 is equal to minus 3a3, a1 is equal to minus 3a3. So by this we know a3 value, so we will get a1. Okay, now you use any equation that it consists a1 and a3, a1 and a3. See here a1, a3. Okay, in this equation substituting the value of a1 and a3 you will get a2. Now we know all the three constants. You can use any equation to find the a1. You substitute a0, a2, sorry, a1, a2, a3. So you will get a0. Okay, you don't follow any procedure here. You just see that you need to find all the constants by using 4 equations. Okay, so now I got 4 values a0, a1, a2, a3. You substitute a0, a1, a2, a3 in this polynomial equations. a0 is half, a1 is minus 3 by 4, a2 is 0 and a3 is 1 by 4. Substituting all the constant values, okay, Hermite shift functions it is 1 by 4, 2 minus 3 zeta plus zeta cube. Okay, this is the first Hermite function. Similarly, you use this second bound, these 4 values to find the Hermite shift function 2. h2 value is 0 at zeta is equal to minus 1, h2 value is 0 at zeta is equal to 1. Similarly, dou h2 by dou zeta is 1 at zeta equal to minus 1. These are the 4 conditions. It is like this fashion you write, and similarly you take this same equation, h2 is equal to a0 plus a1 zeta plus a2 zeta square plus a3 zeta cube, and you will get 4 equations and simplify it, find the constants and substitute in this equation. Okay, you continue it, do it in the same fashion and find what is h2. Okay, n by 4, 1 minus zeta square plus zeta cube. Similarly, you find h3 and h4. Okay, these are the 4 Hermite shift functions. Okay, thank you.